Hi, welcome back to Make Shit Run. Today we've got a special case behind us, 2001 Chevy Monte Carlo, and it's having a problem with stalling. The lady that drives this particular car said that it's died on her several times, and so her description of it was indicative of probably a fuel pump, but we're gonna go ahead and check and see what we can find out. She said it would cut out and it would like hesitate and buck back and forth, as she would call it. And so we're gonna check this thing out, see what's going on with it. I do have a fuel pressure gauge hooked up to it, so I can monitor the fuel pressure while I drive, and that way if the car starts to hesitate and fall over, I can check the fuel pressure and see if it's because the fuel pressure is falling off or maybe something else. So I do have leak-proof connections here, and I ran it up to the actual windows so I can monitor the fuel pressure while I drive the vehicle. Alright, so So right now it's got a rest pressure of about 40 psi, which is pretty good. Okay, tells me the check valve in the pump at least is okay. All right. That's not good either. So that leads me to believe that that's not good. That's another possible power failure. Oh yeah, crazy. But we have rock steady fuel pressure. So whatever this problem is on this car, it is not fuel pump related. It doesn't want to start. Alright, so I'm getting some intermittent lights, dash. This car did have a connection problem one time before down on the starter, so we're going to jack this thing up, get underneath, and check the battery cable again. Make sure it hasn't wiggled itself loose. But that's kind of what this thing is indicating. It's getting power, losing power, getting power, losing power, and intermittently just trying to crank it over gave me that indication. And now the car doesn't want to start at all. Yep, all the power, even the fan went off. Something's not right. Alright, well, let's get underneath and check it out, see what goes on. Alright, welcome back to Make Shit Run. Out here with the Monte Carlo. Again, we were looking last night at the fuel pressure. While this thing was having problems last night, it wouldn't even start back up. Now it's running smooth like it does. It'll run for a while, and all of a sudden, as you're driving, it'll start jerking, hesitating, basically cutting on and off. You'll actually see the tachometer flipping back and forth between about 0 and 4,000 RPM when it does that, almost like it's resetting. So I don't know what we got here. It acted like an ignition system failure, almost like maybe a crank position sensor does when it starts to go bad. So what we're going to do is, well, we went and we looked at the codes. Codes were catalyst inefficiency, slow, O2, stuff that's not going to cause bucking, jerking, hesitation, stalling, that kind of thing. Clear out the codes, we'll drive the car again, reset all the monitors, see what comes back as far as codes. But also, if this thing starts to act up again, will it set the check engine light on, and what code might come back up. But in the meantime, we'll hook up the scope to the crank position sensors, get a waveform out of them, see if we can get the car to act up. We'll let it run here some more, warm up. It doesn't seem to do it till it runs a certain amount. It only seems to want to do it when it's driving. Below a certain RPM, everything is fine. Above a certain RPM is when all this stuff starts to happen. So we're going to hook up the scope to the two sensors, run the vehicle, take a pattern. We'll show that to you, and then we'll leave it hooked up and see if we can't get it to fail, or see if we can't get it to act up, and then see if our wave files or waveforms change any, or may have something to do with it. If not, it seems like it's a main power circuit type of problem. Maybe dealing with maybe even a bad ignition switch of some sort. So, I don't know, we'll keep looking at it and see what's going on, but we definitely know it's not a fuel issue. Fuel is again rock solid. Okay, it has never wavered any time during the testing. So we know that the fuel system is good. So we need to look at the ignition system or the main power. Now, I went down, I checked all the connectors at the starter. Everything is tight. All the wires are in good condition. Nothing's touching anything. Cables are tight. Very tight ground to the block as well. So everything is hooked up. The main power wire going to the power distribution box is nice and tight. Everything good on that end. I pulled the relays, checked them out. No pitting and no scarring on the actual terminals, which would lead me to think that maybe they were getting an intermittent connection every once in a while. But we'll keep an eye on those as well. It was weird because last night, trying to crank it a couple of times, it would like shut off in the middle of trying to even crank it over. It would try to start and it wouldn't go through a complete cranking cycle. It would try to start and then stop. This could also again be just the intermittent ignition problem. So we'll check it all out, see what we can find. Okay, so we got something weird here. We're looking at both the crank sensors. 3X crank sensor, maximum RPM 4021, max over here 1720. The 3x goes up and down and changes scale as it should. I thought there was something wrong with the scan tool, but it wasn't. This sensor, the 18x, is maxing out and topping out. So even when I try to really rev it up, where I got a significant increase right here in RPM, over here I didn't. So we're going to hook up the new meter. Got the new snap-on meter here, and we're going to hook that up. Got rid of the Craftsman piece of junk, and what we're going to do is hook it up, and then we're going to also hook up the scope, and we're going to look at both and do a comparative analysis and see if the frequency really is topping out. If it is, then I know for sure I've got a bad crank sensor, because that signal is topping out at a certain RPM and that's it. It's probably cutting out. So we'll check it out here and we'll check back. Alright, here we are. We got the low resolution crank sensor. This is the 3X low resolution. It's jumping around a little bit because I just knocked it off. There we are. Okay. So it's running between 78 and 85 hertz. A couple of 90s there. And the reason why that's doing that is because the actual time interval between the events and the amount of on time or duty cycle between the events changes. This is so that the vehicle knows which cylinder is coming up on top dead center. Actually, which two pistons are coming up on top dead center, and the cam position sensor helps to let the computer know which one is on compression stroke. If I can speak right. Over here we have the scope pattern. I don't know if you can see it. It's a little bit right there. So the green is the crankshaft position sensor. That is the low resolution. As you can see, the width of the waveform keeps changing because that's the signal to the computer which two pistons are coming up on top dead center. The one below it is a nice constant waveform, and it's a nice steady duty cycle, does not change. So if we did a frequency test on that, it'd be much more stable. But the reason why we have the frequency jumping around a little bit on that low resolution side is because there's different spacing or different on time, which we call the duty cycle, changes with each one of the events. Okay. Alright. Now if we take this down here, switch it over to the high resolution, you can see it's running much more stable, running between 254 and 261. Right in that area, very stable because the duty cycle does not change, doesn't affect the overall frequency reading. When you have something like that where you have a different duty cycle for each one of the events, it can actually make the overall frequency jump a bit. That's nice and steady. We're hooked right down here at the ignition module where the crank sensor signals come directly to, and from there they're distributed to the computer, and then timing and all that is sent back into the ignition module. Okay. So far so good. We have a good waveform. Oh, there we go. We have a good waveform. And nothing is cutting out yet either, so we need to get the car to fail and then retest to see if either one of these signals is the culprit that is giving us fits. Alright. Well, let's see if we can make this shit run. Alright, welcome back to Make Shit Run. We're back here with the Monte Carlo, done some testing. We tested the crankshaft sensors. We got good frequency out of both of them. We got good waveform out of both of them. Of course, that was when the car was running. Now, just like last night, the car is on the fritz again, deciding that she don't want to start. And that's the longest cranking that I've got so far. Well, and there it goes, starting again. Well, there's a reason for that, because I was around here messing with this stuff, and I was thinking maybe there was a main power problem with one of the cables, and I kept moving the cable and having a problem. And the thing would stall. And then all of a sudden, I could tap on this, and every time I do, the fuel pump relay kicks in and you can hear fuel running through the fuel rail. Just by touching the connector. Actually, I was bumping the side of this. Right there. I tapped on the first coil. And you can hear it. And when it does that, it's also sending impulses to the injectors, and when I wiggle this back and forth, you can hear them, they freak it out. I was getting RPM signals up to 32,000 RPM just a little while ago. And that's me wiggling it. You can hear the injectors just fritzing out. So, there it was. Bad ignition module. it may or may not want to start back up. It will now. And the reason why I didn't want to start there is because I was wiggling those injectors. They basically dumped the entirety of the fuel rail into the cylinder, so it was flooded. In this state right now, it'll run just fine. Okay, there it was starting to cut out a little bit. And again, tap on this coil here. Ooh, hear that? Oh, yeah, damn it. It's supposed to make shit run, not make shit die. Alright, well, there's our culprit. We're going to go ahead and replace the ignition module. And what the hell, why not the coils? When we get them off, we'll test them and see how far they are off. If they're in good shape, we'll keep the coils. But, yeah, we got a problem here with the ignition module for sure. So, we'll, there it is, turned everything back on. Now she should start up and fire again, I believe. Yep. There we are. Run, run, run. Except for when I... Now that is something else, let me tell you. Down here, fishing around, checking the battery cables. Oh, there she wrote. Make shit run. Alright, so we're out here. We got the ignition coils off the module. Just to be sure, I'm going to go ahead and do a resistance check on the coils. Make sure they're all good. This 1-4 coil was the one I was tapping on, and there was, of course, a problem. But yeah, problem was more pronounced when I messed with the connector to the ignition module. So 99% sure the problem is in the ignition module. But I just want to check these coils to make sure, because we don't want to hook up a coil that has too low resistance in it and then burn out the new ignition module, or have one that's shorted or open or something like that. So we're going to go ahead and do a resistance test on these. Turn this on, go ahead and turn the backlight on, and let's see, we're going to go to ohms. Alright, so the first thing we're going to do is we're going to check the secondary circuits of all the coils, because that's the easiest one to do. They're right there on the top and easy to access. So we'll hook one lead up to one coil and hook the other lead up to the other coil. 6.18K, so 6,190, 190 ohms. Kind of low. I'd expect it to be a little bit higher, maybe in the 10 to 12K, but we'll see what the other coils test out at. Alright, of course, doesn't want to go on here. There we go. .14, so right on the money, within about 40 ohms of the other coil. Okay. And 6.16, right in the middle. So the secondary windings on these coils are definitely good. The primary windings, however, the ones I'm really suspecting could be a problem because they're the ones that directly connect into the circuit board on the ignition module. Okay, so we're going to get a couple of little adapters, spade adapters that we can hook into the bottom. They have these little slide connectors right here. So we're going to check that out, and boy, connector in there doesn't look all that great. So we'll take a look inside there better. This is the other one, its brother, which looks a little bit better. Anyway, we'll clean it up, see what it says, and we'll hook the leads up to that one, show you what they say. Okay, here's our first coil. We got the wires hooked up into there, and we've got basically half an ohm, 0.5 ohms. It's supposed to be low ohms. Low side can be anywhere from 0.3 up to 1.5, sometimes almost 2 ohms, but I've never seen one more than 2 ohms. It's usually in the 1 to 1.5 range. 0.5 is okay for my testing right now, because we're going to compare that to the other 2 coils. So this is the first coil. This is the one that I suspected might have a problem. Let's see what the other 2 look like. Alright, coil number 2, same thing, 0.5 ohms, right where it should be. Okay. I don't want to replace these coils if we don't have to. $38, $40 a piece. So there we go, second one. Good. Yeah, there's the third coil, 0.5, 0.4, same thing, same temp, same ohms on all of them. So coils are in good shape. We'll go ahead and get an ignition module, throw it in this puppy, and then see what we got from there. All right, make shit run. All right, so we got a new ignition module. We're gonna hook it up. We got our coils laid out and kept them in order to make sure that when I put them back on the module, they're in the right order, and that way, of course, the firing order is in the right order. Now, it doesn't matter, I could switch them as long as I knew which wires were which, but this makes it easier, and I don't want to be confused the next time I or someone else works on it, thinking that the firing order is out of whack. So it's a good idea to make sure you put the coils back in the right places in order to make sure that the wires match up with the firing order. Okay, so we're going to put this back together, and then we're going to retest it and see how she comes out. Alright, we'll see what happens here. Okay, so we got the ignition module back on, the coils back on, wires in the right place. Let's start it up and see what happens here. Try not to trip over jack stands. Alright. Okay, very nice. Start it up. Nice stable RPMs. Let's go knock on that coil again and see what happens. Nothing. Mess with the wiring harness. Nothing. Battery cables, wiring harness, nothing. There we are, folks. She done, she ready, she gone. Alright. Till our next great adventure, remember to make shit run. Alright, so what I have here is I have a scanner movie of the instances that I was looking at in this, on the scanner, to check to see what was going on with things like the crank sensor, RPM signal, looking at map grams per second, looking at injector pulse width, looking at crank sensor RPM for both the 18 by and the 3 by, so the low resolution, high resolution crank sensor. Okay, Also, overall engine RPM, the RPM signal that the computer is looking at. And what I noticed right off the bat, and while I was cranking it over and recording the movie, was some of the values here. So for this engine RPM value right here, okay, engine speed RPM, max value cranking was 10,405 RPM, and you can see the spikes. Now what is happening here is these are two separate cranking events. So I tried to start the car twice, and there's the first one, there's the second one, okay? So we didn't get a cam signal sensor present on the first event, but we did on the second event. That is a possibility because, again, we were just cranking it over, okay? MAF, grams per second, we had some airflow during the cranking event. Okay, also here we had injector pulse width where it was trying to open the injectors. Okay, down here we have the 18 by crank sensor, and it's 998 RPM because the car did try to start a couple of times. So obviously this crank sensor right here, this one is correct. Okay, over here this one says maximum 52,429 RPM. Okay. Now, some would think that, okay, the RPM's off, that signal is off, there's something wrong with the crank sensor. Well, we did a scope of the crank sensor, and the crank sensor signal came out okay. What was happening here, again, like we saw earlier, was there was a glitch in the module, and so with this glitch in the module we were getting erroneous signals and erroneous errors that were causing these RPM spikes. Okay, this is the reason why it wasn't starting. As I moved the connector around, as I moved the wiring harness around, I was able to start the car. Once I got the car started, I could wiggle the harness or tap on the coil and cause the car to fail. What I wanted to do was get a recording of what was going on during these cranking events, and sure enough, this is what I found. Overall RPM, engine speed RPM, again, 10,405 RPM. That's a maximum during the two cranking events. Okay, down here, the 3x crank sensor, 52,429 RPM. Again, spiking during the two cranking events. Over here, the 18 by crank sensor is doing what it was supposed to do. As you can see, it has a maximum of 998 RPM because the engine did try to start a couple of times. Okay, it hit a maximum of 998 RPM. There's nothing wrong with that signal at all, and that's what I would expect. Okay. So that's the nice thing about being able to record events like this, or put it on record mode, go out, take the car for a drive, and then let it mess up, come back, and then look over the recorded files so that you can see the telemetry without having to try to catch it or watch it or look at it while you're driving the vehicle. Of course, that's unsafe, as you know, looking at or trying to use your cell phone while you're driving a vehicle. So again, just wanted to show you what it looked like on the scan tool with these events, and what led me to believe I had a problem with the ignition system, and started focusing on that. Alright, so hope you learned something, and again, as always, make shit run. Alright, welcome back to Make Shit Run. We're here with the 2001 Monte Carlo that we did some ignition work on, and upon further inspection, replacing the ignition module and working with the coils and stuff, I noticed that the first of all, the wires were original AC Delco wires. Didn't look like they've ever been changed, but there was also some nicks and stuff taken out of them by what looked like a mouse, and in the back there was some indication that a mouse was trying to go after the oxygen sensor wire. So there was also a wire down here in the front that had a big gash taken out of it. So went ahead and got a set of wires, put them on. But what I wanted to just kind of go over was, when you're doing wires, try your best to keep the factory wire looms intact and make sure that you properly route the wires and spread them apart. Don't tie the wires together with wire ties. These wires are carrying a lot of electricity, and then they can crossfire, they can induce a voltage into one another, cause terrible feedback in the ignition system, and cause other problems. So again, we ran the wires as they should, and under here, each one of these wires going through here has a protective shield in order to keep them from rubbing or chafing on the motor mount, because they know that's going to move around a bit. They go down here, there's a wire loom right here. Down in the back, there's another factory wire loom. You can't see, I'm sorry, the phone camera won't focus down there, I don't think. But there it is. You can see the other ones. But do your best to try to open those up and reuse them if possible. If not, the kit did come with some extra ones that I am going to run on these wire looms. I'm going to put the extra ones on there just to keep the wires in a nice spacing. But that's a nice feature. At least the wires came with a couple of these, just in case you had a problem or the original ones broke. But just a quick tech tip: make sure you keep adequate spacing on your wires. Make sure you reuse the factory wire looms if possible, and if not, replace them with suitable ones that will keep the wires off the exhaust manifolds, keep them apart from each other. Never wire tie or bunch the wires together. Alright, make shit run.